So today we will be discussing on discriminant analysis. Little bit we have discussed yesterday that it's a classification problem where the dependent variable is categorical and the explanatory variable or independent variables are numeric in nature. So we should know what is discriminant analysis. So it's a classification problem as we discussed where two or more groups or clusters or populations are known in advance and one or more new observations are classified into one of the known populations through the known discriminant function which we create based on the measured characteristics. So in discriminant analysis, the dependent variable is a categorical variable, maybe dichotomous or having more than two categories, whereas independent variables are metric or numeric in nature. So discriminant analysis is also sometimes known as discriminant factor analysis or canonical discriminant analysis. Now, what is the purpose of that? So basically the classification is the purpose here. The main purpose is to classify a subject or a unit into one of the two groups or more groups, whichever the case may be, on the basis of some independent traits or say independent variables. A second purpose of the discriminant analysis is to study the relationship between group membership, that is that class, and the variables used to predict the group membership. What is the relationship between that particular latent say variable and the main variable that is explanatory variable in the consideration in terms of the group members. Development, what is the objective? That development of discriminant functions on the basis of which we classify the observation in one of the predetermined categories, and examination of whether significant differences exist among the groups. This is very important, or they are very similar to each other. So there must be we check whether there is significant difference among the groups or not in terms of the predictor variables which we are using. So discrimination of which predictor variables, determination, not discrimination, that we make the discriminant function, and here we determine determination of which predictor variable contribute to the most of the intergroup differences. Which variable, explanatory variable or independent variable or predictor variable each, contributing the most in the discriminants discriminating among the categories of the group or say different groups. So how it is capable in contributing the most in inter group differences. Now you and one of the another objective is to evaluation of the accuracy of the classification. This is very important because we search for the most efficient discriminant function so that it may be correctly classified to the particular group, because misclassification problem is also there in with that discriminant function. Now these are the some of the applications to identify the characteristics on the basis of which one can classify an individual as. So here we have to also define the independent traits on the basis of which we decide whether an individual is a basketball player or a volleyball player on the basis of the anthropometric variables. So we have to decide the effective anthropometric variables, or we are just classifying the group as a high or low performer on the basis of the skill. So skill variables we have to define. Junior or senior category on the basis of the maturity parameters. So we have to define the maturity parameters first, which are effective in nature, and on the basis of that we will classify the persons as junior or senior. Now these are some of the assumptions. First one is with the regarding sample size. So sample size, group size of the dependent should not be grossly different. It means the difference between the groups sizes, the variables and observations in between the group should not be like 80-20. So it should be a balanced group. The group should be balanced. So here logistic regression may be preferred. If there is a situation that different categories are different groups and the observations among the groups are not balanced, then we should not go for we should not prefer this discriminant analysis. Rather, we should go for the logistic regression. And sample size should be at least 5 times of the number of independent variables. If we are dealing with say 10 independent variables, then at least 50 observations should be there to deal with the this discriminant analysis. Now, obviously, since we are using independent variable as numeric, so they must be normally distributed. So each of the independent variable is normally distributed. This is one of the major assumptions. Homogeneity of variance should be there. That is the variability among the groups should be similar. So all variables have linear relationship. It means the variance among different groups, observations among groups should be similar. And outlier, obviously outliers should not be there in the data. So outliers should not be present in the data. So discriminant analysis is highly sensitive to the inclusion of outlier because so classification, misclassification may be there. So it is highly affected by that. So first we have to clean the data for outliers and extreme observations. And definitely this assumption should be fulfilled that all the groups should be mutually exclusive with every subject or case belonging to one and only one group. There should not be a common variable among the groups or say common unit among the group on the basis of all variables. There should not be common unit. Classification, so each of the allocation of the dependent categories in the initial classification are correctly classified. It is that initially we have correctly classified. If we have misclassified, then that discriminant function will not be up to the required efficiency. And variability should be there. No independent variable should have a zero variability. It means at least some variable, the observation should not be constant on any of the independent variable in either of the groups formed by the dependent variable. So little bit variability should be there, and in we expect that the variability among all the groups are similar. These are some terminologies to be used for the discriminant analysis, that variables in the analysis are the independent entities and discriminant function is a latent variable. So a discriminant function is a latent variable which is constructed as a linear combination of these independent traits or independent variables, such as z is the latent variable, and here we have c plus b1 x1 plus b2 x2 plus so on plus bn xn, since we are dealing with the n independent variables. So the discriminant function is also known as canonical root. Canonical discriminant function or say canonical root. This discriminant function is used to classify the subject or a particular unit or case into one of the two groups or more, as the case may be, on the basis of the observed values of the predictor variables. So we get the values for a unit on these independent traits, say x1, x2, xn, and on the basis of that, we classify that particular unit in the predetermined group. Classification matrix, this is very important in discriminant analysis. It serves as a yardstick in measuring the accuracy of the model. And this is very important in classifying an individual or case into one of the two groups or more, as the case may be. It is also known as the confusion matrix, assignment matrix, or prediction matrix. So this classification matrix is also known as confusion matrix, assignment matrix, or say prediction matrix. It tells us as to what percentage of the existing data points are correctly classified by the model developed in DA. So this is very contrary to that, we are also able to see the percentage of misclassification. So if misclassification percentage is higher at higher level, then we search for another discriminant function. So stepwise method of discriminant analysis That is why we do step-by-step discriminant analysis, which variable should be added or not. So discriminant function can be developed either by entering all independent variables together or in stepwise depending upon whether the study is confirmatory or exploratory. If it is confirmatory, then we can add all the variables. If it is not confirmatory, then we should start from one variable, then keep on adding one by stepwise regression. That is stepwise function. Power of discriminatory variables, that after developing the model in the discriminant analysis based on the selected independent variables. See, it is very important. The selection of independent variables which are effective in nature, which are capable in, which are, contributing in discriminating a variable in the classification. So it is important to know that the relative importance of the variables so selected. So we should know which one is important. This test is very important, box M test. So by using box M test, we test a null hypothesis that the covariance matrix do not differ between groups formed by the dependent variables. If the box M test is insignificant, it indicates that the assumption required for DA holds true. That is problem of sphericity is there if we are dealing with more than two groups. And if we are dealing with the two groups, then equality of variance is that problem. So here through box M method, the null hypothesis is considered that the variance among all the groups is same, and alternative is that is not same. So here it works well if the variance among all the groups is same. So that is we will see through the box M test. It should be whether it is so p value should be greater than 0.05, means that test should be insignificant. And eigenvalues that we have seen that tells about the goodness of fit of the model. So eigenvalue is the index of overall fit of the discriminant function. Wilks lambda, sometimes it is also known as the measure of bad fit. So it measures the efficiency of the discriminant function in the model. Its value shows how much percentage of the variability in dependent variables is not explained by the independent variable. See, it is just contrary to the R square. So R square, that is a coefficient of determination, that is goodness of fit, that is measure of goodness of fit. So it is the measure of bad fitness. So here we check whether so it just explained the percentage of variation not explained by the model, and there R square tells about the percentage of variation explained by the model. So it is contrary to that, complementary part of that, say. So canonical correlation, this is very one of the important measure. So the canonical correlation is the multiple correlation between the predictors, that is explanatory variables, and the discriminant function, that is Z. So that is canonical correlation is nothing but it is the correlation between Z and x1, x2, xn, like that. So here we are just calculating the multiple correlation. So this is the correlation between Z and x1, x2, xn. So with only one function, it provides an index of overall model fit, which is interpreted as being the proportion of the variance explained. So it is just like working like, since it is the multiple correlation, so square of that will represent the coefficient of determination. So these are these two, Wilks lambda and canonical correlation, are complementary part of the study. Now these are the steps involved while performing this discriminant analysis. That in step 1, the independent variables which have the discriminating power are being chosen. A discriminant function model, or say function, is developed by using the coefficients of independent variables like regression coefficients. And in step 3, Wilks lambda is computed to see the goodness of bad fit, testing the significance of discriminant function, how much it is not explaining the phenomena by the model. And in step 4, the independent variables which possesses importance in discriminating the groups are being found, because we can see how much percentage of the variation is not explained by the discriminant function. Now let us do it with an example in SPSS. So to identify a player into different categories during the selection process in a cricket training camp. This is one the example. So these are say parameters, different parameters, different variables under consideration, on the basis of which we have to select the particular person as a bowler or say batsman. So here height, arm length, leg length, palm length, and shoulder strength, reaction time, and speed, judgment time, patience, and player. So here are some, these are the variables, numeric in nature, and the basis of which we will be able to explain that. So this is back explosive power, so, speed and movement, patience, and player. So these are the explanatory variables which are numerical in nature. We will see the normality and go for the discriminant analysis. So these are the observations on these variables and how to perform this in SPSS. And that is, go to analyze, then classify, and there you will see the discriminant analysis, and just click on that. So this dialog box will be opened, discriminant analysis, and there you have to define the group. So define the range, how many groups you are making for the dependent variable. So here if we are making two groups only, that say one for the bowler and another one for the batsman, so minimum is 1 and maximum is 2, and click on continue, and then go for the statistics and put all the variables from here to dependent variables, independent variables here in the independent variable box. Now explore the options one by one given in that. So if you go for the statistics, then we can have idea of our values of say means, and box M is very important, and go for the if you wish, then Fisher's coefficient and unstandardized coefficient, whichever you wish. And if matrices you wish, then you can have idea of that as well, and click on continue. Then explore the another one, that is classification, and go for the classification. So you have to display the case wise result and summary table like that. And if you wish to have uh, some I mean that if you wish to have some graphs, plots, then also we can go for the combined group or separate group like that, and just click on continue, and then explore the another one. We can go for another options as well and see the output. So this type of descriptive statistics table will be made here, that batsman and bowler, and these are the totals. So these are the means and standard deviations, and these are the cases. All 20 cases are here. Through box sum method, what we see that p value is very much greater than 0.05. It means the homogeneity of the variance among all groups is hold. So here it's good to go ahead for the classification. Now here we can see here standardized canonical discriminant function coefficient is given here. These are the coefficient for the variables under consideration, and these are the important variables which are being selected for to create the discriminant function. See here, only these variables have been considered for the discriminant function, that x1 height, back explosive power, judgment, and patience. So now we have made this discriminant function, and these are the coefficients you can see here, this one, and these are the regression coefficients. And now just put the values of x1, x2, x3, x4 for any unit. You can see the value of z, and on the basis of that we can classify in one of the groups. See here, these are the eigenvalues. So canonical correlation is good, and eigenvalue is very good for this function, 13.2. And if we see the Wilks lambda, so it is uh, it is having value 0.0, it is 0.07, and it is significant 0.000. So p value is very much less than that. It means the model is of good fit. Now this is the classification. You can see here all 20 batsmen and 20 bowlers are here, and this is for the percentage. 100% are given in the data. This is classification result. So this is the final standardized canonical discriminant function coefficients. On the basis of that, we can make the function. So these are the value of the discriminant function for that. If close to this one value, we will classify to as batsman, and if values are closer to that, then we will decide that the person is a bowler. So now let us do it on hands-on. Let us do hands-on on SPSS, and then we will be entertaining the questions. For the two group case, so here is the case that we have a case study of the buyers, say on the basis of say bike buyers, whether they will purchase a bike or not purchase the bike on the basis of that on the basis of the durability variables, durability, performance, and looking. So on the basis of that, we will classify that the person will purchase the bike or not. See this one, purchase and would not purchase. So first we should see the normality of the data, independent variables. So go to analyze and their descriptive statistics, and there you will see explore. Put all continuous variables here in the dependent list, and just go to plots, and there you just put tick on this one and remove this tick here, that normality plots with tests, and then click on continue and just click on OK. So you can see here, this is descriptive statistics, but go with this one. So you can see here that this data is not normally distributed. So we can search for the outliers here. Thus durability of the bike is not normally distributed because p value is less than 0.0. So all variables are not 0.05. All are not normally distributed because here the example has been taken for the 100-point scales. We have actually this is say categorical. So first we should see whether it is normally distributed or not. So here all the p values are less than 0.05. It means the data is not normally distributed. So first we should take more and more data to make it normal. But just for the demonstration, let us do it. Now how to perform this analysis? Go to analyze, and there you will see classify, and in classify this discriminant analysis is there. Just click on that. Now you have to put all the independent variables here. First you define this grouping variable, and you have to define the range. So 1 is minimum and 2 is maximum. Click on continue, and then you have to select all the independent variables here and just explore one by one. Just go to statistics. So I need means, I need box M method, and say we need Fisher's and unstandardized coefficient. Just click on that and classify. Then whether which we need summary table, and if anything else you need, say case wise result, then you can click on that. And if you wish to save the value of the predicted group membership, discriminant score, and probability of the group, everything you can save. So you will see here that in these columns these values will be saved. Bootstrapping is not needed here. Just click on OK. So you can see here, this is the summary processing, that 80 observations are there, and so 100% are present, no missing observation is there. And you can see here purchase and would not purchase, so 40% are there. And you can see here these are the means and are the standard deviation for these variables. So you can see here durability of the bike. So purchase is giving the mean is 71 for the durability of the bike, and it is 30 only for the would not purchase. So the person is not emphasizing on the durability of the bike who would not purchase, like that. And performance, it is 44, it is 66, and it is 38 and 39. So looking are almost same for the for both the groups. Okay, so now let us see another measure, that is box M method. So you can see this is box test, and you can see here the p value is very much less than 0.05. It means the variance among the two groups are not same, but we consider that it must be same. So it is imbalance type of groups here. So this is because of the non-normality of the variables. Just for the demonstration, we are considering it, but we should have normally distributed independent variables. So don't bother about that. Just see the demonstration of the data analysis. Eigenvalue is 2.3, a little bit lesser, and the canonical correlation is 83%. So it is good, 84%. So it square of that, so almost 65% of the data is explained by this discriminant function. And Wilks lambda is significant, it is good, that it must be significant. And you can see here this is the discriminant function one, standard. These are the coefficients for the that discriminant function, and this is structure matrix. So you can see here this is the revised pooling the group. These are the coefficients of the that particular discriminant function. So now we can make the discriminant function. So canonical discriminant function coefficients are finally here given, that these are the final. So we can make the function here, discriminant function z as minus 3.44 plus, or say minus, or if you are considering this as first x1, then first and 0.063 x1 plus 0.022 x2 minus 0.027 x3. Now if any customer is coming, so we will get the score on these three variables, and we will see the value of the discriminant function on the basis of these coefficients, and which one is close. We will see which one that one is closer to this one or this one. On the basis of that, we can decide whether it will purchase the bike or would not purchase the bike. So this way we can see the. So these are the probabilities and classification function coefficients. So here see, now classification coefficients are also given here. So on the basis of this, we can calculate whether the person would buy the bike or would not purchase the bike on the basis of these two. So this value must be close to that minus 1.5, which one is given here, value of the discriminant function, and the first one should be close to 1.52, and the second one minus 1.2. So for both the variables, you can also use these coefficients, and you will see whether it is going to, through these functions, we will be able to see whether we are correctly classifying the particular unit in the group, or it is going to be misclassified on the basis of the total value of the discriminant function. So these are the case-wise statistics. You can see here these stars are showing that we have misclassified these in groups. So these must be in first, and but here we have misclassified them as second on the basis of the discriminant function. See here, these has been calculated for all the units. See discriminant score. So on the basis of discriminant score, we will be capable to see whether, see, it should be very close to minus 1.5, but it is 0.5 only. So we have misclassified that. So this way we can we can make another discriminant function with higher efficiency, and misclassification problem should not be there. So you can see here this one is 7s are misclassified like that, and here one is misclassified like that out of 40. So this way we can classify the problem, and this see the 90% of the cases are correctly classified. So this this model is having 90% of the efficiency of the classification. Now let us do it fast for the see here, these are the observation probabilities are saved for this example, which we have calculated membership function and different discriminant score and the probability of that. So on the basis of that, we can also calculate whether we are correctly classifying or misclassifying the particular unit to a particular group. Now let us do it for the 3 groups. Okay. So these are the, this is the data that we are just, we have given 1, 2, 3 as the coding for the large quantity purchase, and say medium quantity purchase and low quantity purchase. And these are the 3 things, independent variables, that is income and perception and the age. This is the, example for the say tendency towards the purchasing in shopping malls. So first we can see the normality of the data, and we go to, so to see the normalities we should go for the descriptive statistics, and there you will see the explore, and then put all the independent variables, that is numerical variable here, in the dependent list, and then go with the plots, and just click on normality test with normality plots with test, and click on continue, and then click on OK. So you have to see the table only for the normality test, that is Kolmogorov-Smirnov test and Shapiro-Wilk test. You can see here all the variables are normally distributed because p-values are greater than 0.05. So now we'll move ahead for the discriminant analysis. So just click on analyze, then go to classify, and there go for the discriminant analysis, and you have to put this variable, grouping variable, and here you have to define the range. The minimum is 1 and maximum is 3 because we are making 3 classes, and put all the variables here in the independent list, and similarly by the same fashion go to, and this one means, and say box M and Fishers and unstandardized values we need, and just classify that we case wise result we need, summary table we need, like that. Click on continue, and you can go for to save the predicted group membership and discriminant score and the probability of the group membership. All 3 things you can see. Just click on continue and click on OK. So similarly, you can see here 30% are there, valid observations, and 100% are present. These are the summary statistics, that is for the large quantity purchasers and medium quantity purchasers and low quantity purchasers. You can see here. These are the mean scores, these are the standard deviations, and 10% are there for the three groups. Now, if we go for the result, so box M, it is good because 0.0, the p-value is very much greater than 0.05. It means the homogeneity of variance is fulfilled. And go for the eigenvalues. So you can see here, these are the eigenvalues. So there are two discriminant functions, you can see one and another. So first one is having eigenvalues 5.4. So we will go with the discriminant function having eigenvalue greater than 1. So we'll go with that. And 91% or 92% correlation is there. So it is having a good fit. And you can see here, this one is significant and this one is non-significant, second one. So we'll go with the significant because it must be significant. Because it represents the bad fit. It tells about the percentage of the variation not explained by the model. So that is rejected. So it means the model is capable in explaining the phenomena good. So these are the functions. So we are interested in function 1 only. So we will consider these coefficients. So finally, we'll go with a little bit adjustment, this canonical discriminant function. So we can see these are the coefficients and we can make the functions. And if you are classifying, then these are the functions at group centroid. If you go with the good group centroid, then these are the regression coefficients. Otherwise, we will use this function and we will calculate, and on the basis of that, we will see the discriminant score, and on the basis of discriminant score, we can classify the unit into the three groups. So these are the case studies. You can see here, this one is misclassified, this one is misclassified. On the basis of that, this discriminant score. So this was today's discussion. Now, if you have any query, any question, please ask. You can also make the separate the canonical model, this discriminant function. Otherwise, you can use this one as the model. This one coefficient is also considered, and you can see the score. So on the basis of score, we can classify the unit into three groups. Maybe large quantity buyer, medium quantity buyer, or low quantity buyer. So now if you have any query, any question, please ask. These are the probabilities and the discriminant score and the membership score. Now, if you have any query, any question, please ask. You all are, requested to ask the questions regarding this discriminant analysis. Let me put you on whether I can put you on unmute mode or not. Any query, any question? Please ask. No question? Am I audible? First, see, you when you will do, then you will see what we should see and how to do. So first you see the independent variables, select all the effective independent variables, and then which are capable in discriminating in between or among the units, and then see the normality, and then make the discriminant function, and then check the equality of variance among the groups through box sum test, and through the eigenvalue see with what is the goodness of fit of the discriminant function, and Wilks lambda what is the bad fit of that particular discriminant function, and you will see the value of the classification and the coefficients, as well as coefficients you will see after discriminant function, and just you see the value of the new function, and they put the values, and see whether it is close to which one classified that discriminant function value. Then on the basis of that you can classify whether we should put, and if it is very close to any of the it is very clear picture. If it is not close to any of the discriminant function value, then there is confusion, so that may be the problem of misclassification. So we also calculate the probability there. If it is very weak, then that problem may be there, so you have to revise that one. What you wish to see, what you have not understood. Suppose there are, so with example, we have seen that we have so many independent variables, and on the basis of that, we are interested in knowing whether the persons may purchase a bike or not. So we have calculated, we have asked its age, its income, and another other variables, and we have made a discriminant function, and on the basis of that, we can have idea that the whether person is going to purchase the bike or not. So if the new customer will come, and we'll ask the values once we have made the discriminant function. So new person is coming, and on the basis of that we'll ask the questions on the independent variables, and we'll put them there, and we will calculate the discriminant score, and we will have idea whether it will purchase bike or not. Dependent variables are categorical only. If independent variables are also categorical, then we go for the logistic regression. Here independent variables should be numeric in nature. If they are categorical, then go for the logistic regression. So there we'll calculate the probability of classification. Dr. Mansoor, you do practice, and then the picture will be clear. But theoretically, you should be very clear what you are going to do. First, select the effective independent variables, make the classes of the categorical variable, and then make a discriminant function. See the normality of independent variables, see the equality of variance through box M method, see the goodness of fit of the model through eigenvalue, and see the goodness of bad fit through the Wilks lambda, and you can get the value of that discriminant function. This is the procedure. And once we have established the discriminant function and it is working well, its efficiency is high, then we can classify the new coming unit correctly to a particular class. Yeah, any more question? See, it's need practice. Now, if you have any doubt, any question, any query, please ask. That it's time to ask the things. नहीं, हमने कोई अभी तक तो बुक नहीं लिखी है मैम, आगे सोचेंगे। देखिए, ये सब लोगों के लिए एक हमारा सजेशन है, बहुत जल्दी परेशान ना हुआ करिए। दूसरी बात है, कोई कंसेप्ट जब तक क्लियर ना हो जाए तब तक कई किताबें, कई वीडियोज, कई टेक्स्ट पढ़िए। जब आपके हिसाब से, आपके लेवल से बिल्कुल पिक्चर क्लियर हो जाए, देन ओनली यू मस्ट बी सेटिस्फाइड। और कोई एक बार पढ़ने से जरूरी नहीं है कि सबका कंसेप्ट क्लियर हो जाए, बट एक यू मस्ट हैव आइडिया, एंड देन गो हेड। एक एक चीज पढ़िए, विल्क्स लैम्डा क्या करता है उसके बारे में पढ़िए, बॉक्सएम क्या करता है उसके बारे में पढ़िए, और आइगन वैल्यू का क्या कंसेप्ट है। जैसे कल हम लोग कह रहे थे कि दिस इज द स्क्वायर ऑफ द कोरिलेशन कोफिशिएंट्स, तो वो गुडनेस ऑफ फिट को बताता है, तो उसको उसको पढ़िए, देन यू विल बी एन एक्सपर्ट। डिस्क्रिमिनेंट एनालिसिस और मल्टीपल लीनियर रिग्रेशन में फर्क ये है, डिपेंडेंट वेरिएबल कैटेगरिकल होता है यहाँ डिस्क्रिमिनेंट एनालिसिस में, एंड इन दैट मल्टीपल रिग्रेशन बोथ इंडिपेंडेंट एंड डिपेंडेंट वेरिएबल आर न्यूमेरिक इन नेचर। There in multiple linear regression, dependent variable is a numerical variable. It's a metric variable. While in discriminant analysis, it's a latent variable and it is a categorical variable. Yeah, both are done for the prediction. Actually, modeling is for the prediction. Whenever you are establishing a function between dependent and independent variable, it's for prediction. Logistic regression and discriminant function analysis are almost same, but if some independent variables are also categorical in nature, then we go for the logistic regression. And if the ratio of the observations among the groups is imbalanced, that is 80-20 like that, then we go for the logistic regression. No, logistic regression and in logistic regression, dependent variable is categorical, but in multiple linear regression, it is not categorical, it is numerical. Discriminant analysis and logistic regression are similar, not multiple linear regression. So, any more question? Yeah, maybe multiple category. We have considered here three categories. So maybe dichotomous or multi options are there. Multinomial may be there. Yeah, definitely, definitely. If you have data, then I will demonstrate through statistical test, and I will be helping you. Definitely, I will help you. Yeah, multinomial logistic regression. If we are going with the multiple categories. Hmm. So, any more question, or should we wind up? Okay, so no more question or any more doubt? Okay, so let us see you again, and thank you for bearing me, and see you again. Okay, take care. Bye bye. Okay, thank you to all of you. Okay, bye bye. Okay, see you.